These are called special right triangles because they fit two ratios of angles. On the front page, we're going to be working with what are called 45, 45, 90 triangles. I would go ahead and highlight this right here. 45, 45, 90 triangles. They're called 45, 45, 90 triangles because if you look at the image, each of the triangles has an angle that is 45 degrees, another one that is 45 degrees, and then our right triangle marking of 90 degrees. So that's the angle measurements in the triangle. It is formed when a square is bisected diagonally, as shown in this image right here. So we bisect the triangle, we get a 45, 45, 90. Well, we bisect the square, we get a 45, 45, 90 triangle. What happens is there's a ratio between, or a relationship between the angle measurements and the sides. So we're going to create these tic-tac-toe boards, that's what I'm going to call them, for my 45, 45, 90. When you have these measurements for the angles, underneath them, you're going to write x for 45, x for 45, and x square root of 2 for 90. That is the relationship between the sides. So we're going to be able to fill in the entire empty row of these tic-tac-toe boards depending on the numbers you have for either x or x square root of 2 on the side lengths. So I want you to write something down for yourself right here. This row right here is angles. These two rows are sides. I need you to make sure you understand what we're talking about in these tic-tac-toe boards. The top are angles, so those are all degrees, and the bottom two rows are going to be the sides. In a 45, 45, 90 triangle, since these are both the same value of x, the sides are going to be congruent. So the legs are going to be the same number, and the hypotenuse is square root of 2 times as long as each short leg. So let's see what this looks like in real life. We've set up most of the tic-tac-toe boards for you, which is what you're going to do when you're given a problem like this. It says the following are isosceles right triangles, find the missing side measures. I noticed first of all that this is a 45, obviously 45, 90 degree triangle. Across from the 45, what number is that? 10. So underneath one of the 45s, underneath one of the x's, you're going to write 10. Because across from a 45 degree angle is a side length of x, which is a side length of 10, based on the picture. Well, if this is 10, what should I put right here? 10, because it's also x. Okay, if this x is 10, what should I put right here?
Gotta be 2 times?
Square root of 2 times it.
100.
Okay. Thank you for trying. You're actually just going to slide the number 10 in front of a square root of 2. It's just going to look like that. Now, if I was actually figuring out in decimal form what that value was, you would in your calculator do 10 square root of 2. It's approximately 14.14. But I don't want you to answer with decimals today. You're going to answer with the 10 square root of 2 because we're just multiplying square root of 2 by that value of x. So to answer the actual question here, it asks me, what is CB? Okay, CB is this right here. Which side length is that?
That's the 90.
That's the 90, which means we're going to answer that this is 10 square root of 2. If I ask you for AC, that's this one right here. What is that across from? A 45, which means that the length is 10. So the tic-tac-toe board is going to help you find these patterns among these triangles. In a 45, 45, 90, it's x, x, x square root of 2. Can we try another one? Okay, in this one, I still see that based on the image, it is an isosceles right triangle, which means that these two angles are congruent. Since the big one is 90, that forces these other ones to be 45 degrees and 45 degrees. So I know this follows the 45, 45, 90 pattern. What can I fill in on my tic-tac-toe board? Can I fill in a 45, or the 90? 90, because this is the 90, so I'm going to put 8 square root of 2 underneath the 90 part of the tic-tac-toe board. Okay, if 90 is x square root of 2, or it is 8 square root of 2, what is x? 8. It's just the number in front of the square root of 2. So I can fill that in for both of the 45s. So if I answer the actual questions here, this one says, what is AB? Well, that's right here. How long is that? 8, because it's across from a 45. If I ask you for AC, okay, well, now that we're back from the fire evacuation, I forgot what we were doing. Oh, we were doing this problem. The last question I asked out loud was, what is AC? Now, AC is here. It's across from a 45, so how long is AC? Ooh, we all forgot what we were doing.
Wait, what?
Across from a 45,
That's 8.
so it's 8. Okay, whew, we're back. Great. All right, let's look at the next problem here. In question number 3, this one's going to be a little bit different. So it says that we have a 45, 45, 90 triangle. Since this is a 45, this is 90, that means this has to be 45. In my tic-tac-toe board, x square root of 2, they gave me that the across from the 90-degree angle was 12. Now here's the problem. A second ago, number 2 was super easy because we just needed to find out what x was, and it was right next to the square root of 2. So we just pulled the 8 off of the square root of 2. Okay, but this time we were given that the x square root of 2 is 12. So what we do to find x is we take this little shortcut that we've written in here. It says, first, divide by 2. So what is 12 divided by 2? 6. And then it says number 2, multiply by square root of 2. And for us, that means just place a square root of 2 right next to the number 6.
Some of y'all watching, y'all just missed it.
These problems go really, really fast once you have your tic-tac-toe board set up.
Different, so make sure you pay attention to this example.
So again, just to do this one more time, we took the number 12. We did 12 divided by 2, which is 6. And then we multiplied it by square root of 2 to get 6 square root of 2. I don't need you to give me the decimal approximation today. I want the radical answer, the one with the square root in it. So let's answer the actual questions here. The first part says, what is AB? Is that one 6 square root of 2 or is that one 12?
6.
Mm-hmm. Fabulous. And then the next one asks me to find BC. It's going to be the same thing because it's going to be the same length as the 45, 45, 90. Now this last problem, number 4, we've done all the way for you because the math is a little weird. In this problem, we're going to highlight some things since it's all the way done. You were given that the side length across from both of the 45s was square root of 2 over 2. So when you take that to be x and you place another square root of 2 next to it, what happens is the square root of 2 times square root of 2 on the top is going to basically cancel each other out so that it becomes 2 over 2, which means this reduces to 1. But the main thing I want you to do here is when you have a problem that's confusing you with the square roots, you're going to take this tip right here. What does it say to do? Use a calculator. If you use a calculator to do whatever the number is times square root of 2 and it gives you a nice pretty number like 1 or 12, you just use that number. If it gives you a decimal, I need you to pause and try the problem again because you're going to have to give it back to me in square root form with the radical. Okay, let's do problem 5. In problem 5, it says an 8-foot TV shaped like a square is being advertised for sale. Remember, we talked about this last class that when you size technology, you're not talking about the length or the width, you're talking about the diagonal across the piece of technology for TVs, for smartphones, for laptops. That's how they measure them. So an 8-foot TV means that this is 8 feet. It's a huge square TV for some reason. It's being advertised for sale. It says find the height. Since this is a square that is being bisected diagonally, that means that these angles here are 45 degrees. So we are having a 45, 45, 90 triangle within here. To find the height, that means I'm really looking for the height of the square, or the height of the triangle. So we set up our tic-tac-toe boards. This is the first time you're going to have to set it up. So when we do this, we put the angles 45, 45, 90. and you give me 3 rows. We have our angles row, we have our pattern row, and we have our answers row. What was the pattern for 45, 45, 90? Look at the top of your page. What is the pattern? X, X, and X square root of 2. All right, fabulous. What piece of information did they give us in the picture? That 8 feet is across from what angle? 90. So I'm going to put 8 right here. Oh, we need to use our trick that's right above this because I need the X value out of that and there's no square root next to it. So the trick was divide by 2, multiply by square root of 2. What is 8 divided by 2? 4. And then I give it what next to it? Square root of 2. So I divided 8 by 2 and then basically slapped a square root of 2 next to it, which is multiplying it by square root of 2. So what is the height of this square? The height is just one of those side lengths, 4 square root of 2. And if we were actually answering this question, since it's a real life question, you'd never measure something as 4 square root of 2. You'd probably measure this in decimal form. So this is approximately 5.657 feet tall. Imagine a 5-foot tall TV. Yikes. Questions before I move on to the next one. You set up your tic-tac-toe board, fill in the one piece of information you know, and then find the missing pieces of information. But of course, we don't have to stop there. We can ask you further questions like maybe find the perimeter. How do you find the perimeter of something?
Add all the sides.
Add all the sides. So for this square, all of the sides are the same. So I can do 4 square root of 2 plus 4 square root of 2 plus 4 square root of 2 plus 4 square root of 2. But I don't like typing that many times.
Times 4.
We can just times 4. So I'm going to do 4 times 4 square root of 2. Whichever way you think about perimeter works for me, since this is a square. Yes, it means you're just adding up the sides. That's a lot of button pressing unless you just think about multiplying that number. When you do this in your head, before we do it in a calculator, you are only going to multiply the big numbers together. Do not multiply that number inside the square root. So what is 4 times 4? 16. So this is actually 16 square roots of 2, which now if you put that in a calculator is about how many feet? 22.63, I believe, feet. That's the perimeter of this shape. We added up all the sides. We answered with both simplest radical form and a decimal approximation.
I just add decimal.
What do you mean?
I multiplied the decimal.
Oh, that's fine too. We don't want to usually use a rounded number to the very end, so be careful that an answer might be off by a few decimals if you don't use the exact answer. The last question here says find the area, and it gives you a hint that the area of the square, not of the triangle, of the square is base times height. What's the base of the square? 4 square root of 2. What's the height of the square? Still 4 square root of 2. So we're just doing 4 square root of 2 times 4 square root of 2. If you were doing this in your head, you would do the big number times the big number, which is 16. You would do the radical times the radical. What's 2 times 2? What's the square root of 4? 2. So really this would be 32 square feet. If you're like, whoa, Miss Quigley, where did you get the 16 and the 2 from? I multiplied the big number times the big number, 4 times 4. The number underneath times the number underneath, so square root of 4, which is 2. If you're like, still don't get it, Miss Quigley, great, you type this in a calculator. 4 square root of 2 times 4 square root of 2, you would get 32 square feet.
So we type it in like this?
The one on top, 16 square root of 4. Or you would just do this, like straight up type this. Parentheses 4 square root of 2 times parentheses 4 square root of 2. Yeah, like that, you have it in there. Okay, let's take a quick pause and let's see if we get this. So grab your whiteboards back again. I'm gonna put some problems up on the screen and I want you to answer on your whiteboards. Now that we've practiced the 45, 45, 90, our second special right triangle is called a 30, 60, 90 triangle. This special right triangle, so when you have those angle measurements of 30, then 60, then your right triangle 90, you can use this pattern. Yes. The pattern works the same. We're still going to have a tic-tac-toe board, but the ratios are different, so the pattern is going to be different. A 30, 60, 90 triangle comes from a scalene triangle having an altitude drop straight down and cut it in half. So it is bisected by an altitude. These ratios created by bisecting an equilateral triangle create these ratios shown in this scalene right triangle. The pattern is across from the 30 is x. Across from the 60 is x square root of 3. Across from the 90 is 2x. So our tic-tac-toe board changes. Notice now we're using different angles. So these again are my angles. So the side ratios or the pattern and then the sides answers are going to be slightly different, but it works exactly the same. Can we try some with this new pattern? All right, in this one we notice that it is a 30, 60, 90. 90-degree angle because these are right triangles. This one's 30, which forces that one to have to be 60. What piece of information did they give us?
15.
They gave us 15, which was next to the 30. So underneath the 30, I'm going to put 15, which means I just learned that x is equal to 15. Well, if x is 15, what should I put underneath the 60? 15 square root of 3. And what should I put underneath the 90? 30. So the pattern with the tic-tac-toe board works the same. I was told by the problem that across from 30 is side length of 15. So I filled in the 30 column with the 15. That means x is 15. So to make x square root of 3, I just pop the square root of 3 next to 15. To find 2x, I just multiply 15 times 2 and I get 30. So this pattern works the same, but is a little bit more difficult in the patterns because it's not x square root of 3. It's square root of 2, x square root of 3, and then 2x. Okay, let's answer the actual question though. This one asks you to find CB. Now if we look at our triangle, CB is right here. That is across from which angle? CB is? It's across from the unmarked one, which means in this triangle for us, what is that measurement? That's my 60. Underneath the 60, what did we say was that length? 15 square root of 3. It's just the number right underneath the 60. Okay, the second question here asks you for AB, which is here. How long is AB? Ooh, across from AB means I'm across from the 90. So if we look at the 90 column, what's there? 30. Okay, let's look at 7. I've got your tic-tac-toe board set up. I see that this is 30, 60, 90, 90 degrees. 60 degrees, which forces this other one, so that they add up to 180 degrees, to be 30 degrees. What information did they give me?
90.
The 90. So underneath the 90, I'm going to put 22. Now here's where we have to get thinky about some algebra. If 22 is 2 times x, what's x? 11, because 2 times 11 is 22, correct? So I know that this is 11, which means what should I put here underneath 60? That's it. We're just following the pattern. Now to answer the actual questions, this one says I want to find CB, which is this little section right here. How long is CB? CB is the side length across from what angle? It's across from the 30, so I look at the 30 column. How long is it? 11. If I go from A to C, like the second part says, that is across from which angle? From the 60. So the 60 column says that that side length should be? Keep going. 11 square root of 3, yes. Which I know, again, you can put in a calculator, give me a decimal approximation. I don't want that for these math problems. I'll really only want decimal approximations for like real life problems, like our TV problem on the front page. Number 8. Okay, this one's going to be a bit of a challenge, so stick with me. In this problem, what information were we given? We were given that the 60 is 9, so I'm going to put the 9 in that 60 spot. Ooh, but here's the weird thing. I'm used to seeing underneath 60 that it is a number times the square root of 3, which means I have to do a little bit of work to figure out what x is equal to. But this also has a shortcut like on the front page, so let's write down the shortcut. The shortcut, step 1, you're going to divide by 3. Then, oh, sorry, this is to find x, I guess I should say. Shortcut to find x. You're going to divide by 3, and then you're going to multiply by square root 3. So it's like the shortcut on the front where we divided by 2 and multiplied by square root of 2. This one you divide by 3 and multiply by square root of 3, since it's the 60. I don't want the decimal. I want the, you're not going to actually press multiply in your calculator. That means just like stick a square root of 3 next to it. Until we get to a real life problem, I just want radical answers. So my question for you, what is 9 divided by 3? 3. And then we just need to multiply it by square root of 3, which means you just stick that square root of 3 next to it. Yes, 3 times the square root of 3 is 5.2-ish, but I don't want that number. I want 3 square root of 3 being here. Now, we have found x. So to find the 90, all we have to do is double that number. Do not touch the number underneath the square root. You're only doubling the number in front of it, the x value, which means that 90 here would be 6 square root of 3 because it is 2 times the x value. So you just multiply the number in front by 2, double the number in front. When they give you the value of 60 and it is not showing you square root of 3, this is when you need to do this shortcut. But the shortcut is divide by 3, slap a square root of 3 next to it. Yes? Let's see a real life problem. So this is one where we'll answer in actual decimals. It says this danger sign is shaped like an equilateral triangle. Danger. It wants me to find the height of the sign. So I'm wanting to find, let me use a color you can see. I'm wanting to find this height right here. What this problem wants you to realize is that since this is an equilateral triangle, that this becomes your 90-degree angle. This is a 60-degree angle from it being equilateral, which means that this has to be 30 degrees for it to be an actual triangle. I know this sign is hard to write on top of it because it's so dark. If it's too hard for you to see this, I want you to draw a new triangle underneath it just to clear this up. This is 60 degrees. This one would be 30 degrees. And the one piece of information they gave us is that this is 18 inches. Okay. We want to find the height of the triangle. So we want to figure out what this is right there. Since this is a special right triangle, I can use the patterns and the tic-tac-toe boards to figure that out. So we fill out our own tic-tac-toe boards, right small. We have 30 degrees, we have 60 degrees, we have 90 degrees. We make our tic-tac-toe, pow, pow. We fill in the pattern. The pattern for 30, 60, 90, especially, remember you have your orange reference sheet. It's there in the middle. Is x, x square root of 3, and 2x. What piece of information did this image give us? They gave us the side across from 90. So I should put 18, I'll make it purple, 18 underneath the 90. What else do you know now that you know that is 18? Remember, this is 2 times x.
Divide by 2.
So if I divide by 2, what's x?
9.
9. So I'm going to put 9 underneath the x part of it, underneath 30 degrees. So what does that mean about the 60 degrees? 9 square root of 3. Okay, cool. We've got all of our stuff. We just need to answer the actual question here. This height is across from what angle? The 60. So the height of my triangle is 9 square root of 3 inches, but that's a weird way to answer this question. So this is one, since we're answering a real life question, that we are going to put in decimal form. So 9 square root of 3, beep, beep, bop, you type that in your calculator, is 15.6 inches. Again, the real life problems are the ones you move back to inches, or sorry, into decimal form. The rest of them you leave as radicals. Okay, cool question. It asks me to find the area of the triangle, the whole sign itself, not the little purple triangle we made, but the whole one itself. And it goes on to tell us that, remember, area for a triangle is 1/2 base times height. So I just need to fill in the base and the height. Well, we just found the height of this triangle. What was it? 15.6, but I want you in the middle of a problem, don't ever use a decimal number. I want you to save the decimal numbers for the very end, which means I'm going back and I'm plugging in the radical version. We did this last class with some of our triangles as well. Don't use the rounded number to the very end. New question though, what is the base of this danger sign? 18. Since it's equilateral, all of the sides are the same. So if this one's 18, this one's 18. So I'm just doing, in my calculator this time, 1/2 times 18 times 9 square root of 3, all at once. When you type that in your calculator, you get it all at once. You would get approximately, hopefully, 140.3 inches squared. Since we're finding area, we do have to square that. If you're interested in doing well on your SAT would probably answer this question with the radical version of this, which means you just multiply all of the numbers and stick the radical at the end. This would actually end up being 18 divided by 2 is 9. 9 times 9 is 81. It would be 81 square root of 3 inches squared. That's a very common way that SAT likes to answer this question. Us in real life, if we're actually measuring the sign and somebody answered to you 81 square root of 3 inches, you'd be like, I don't care. Give me an actual number. And then they say, oh, 140.3 inches squared. You'd be like, okay, that makes sense. So just make sure you communicate answers properly depending on what was asked of you. Let's do another application question. It says, this is very much like things that SAT, again, my juniors who are taking their SAT in like 3 weeks. SAT loves this kind of question. The perimeter of an equilateral triangle is 624 centimeters. The height of this triangle is k radical 3 centimeters, where k is a constant. What is the value of k? All right. Miss Caldera drew a picture for us. She said, here's my equilateral triangle. And it gives you the height here. So this image is just like our danger sign where we have 60, 90, and 30 degrees. Which means the tic-tac-toe board I'm setting up is a 30, 60, 90. Again, you saw equilateral. That's our indicator that it's probably 30, 60, 90. The pattern for 30, 60, 90 is x, x square root of 3, and 2x. We just got to fill in some information. What other piece of information did this problem give us? They told me that the perimeter is 624. Is that helpful right now? No, because I need side lengths to be able to do my tic-tac-toe board. But if the perimeter, which means we added up all the sides, so this is side 1 plus side 2 plus side 3, is equal to 624, what does that mean each one of these sides is? How did you get that? Yeah, this is an equilateral triangle. All of these sides have to be the exact same. So that means all of the sides are 208. 624 divided by 3. So if I fill in my picture, that means this is 208 in my triangle, which is across from what? 90. So that means that I'm going to put the 208 right here. Which means, what is the value of x? 104. And what is the value of the 60-degree side? Amazing. All right, so we filled out our tic-tac-toe board. Let's figure out what the actual question was here, because you know how SAT likes to ask multi-step questions. It says, the height of this triangle, which, by the way, the height is across from the 60, is k square root of 3 centimeters, where k is an integer. So what is the value of k? Watch this, watch this. If I say the height is k square root of 3, I also know that the height is 104 square root of 3. So what is k?
104 square root of 3.
It's just 104. Because it's just asking, essentially, what number is in front of this square root of 3? Because these both have the square roots of 3, that means k is just 104. If those are both the height of my triangle. I wrote that kind of big. I'm going to go back and make it a little smaller, just so I have room on my notes. So that means k is 104. Number 11, we're going to find the missing variables, but we got a whole situation happening here. We got two triangles smushed next to each other. We got a 90-degree angle, a 30-degree angle, which means for this triangle that's on the top-ish, what is this angle right here? 60. Everybody put a 60 right here. But the picture itself says that this whole thing, this whole obtuse angle is 105. So if the whole thing is 105, this little bit is 60. What does that mean this little bit is? 45. 105 minus 60 is 45 degrees. Which then for me indicates that this triangle that's on the bottom-ish of the image is a 45, 45, 90 triangle. Whoa, we're mixing them together now. Let's solve some stuff. We're going to set up both tic-tac-toe boards, but since the number I was given, the 16, is a part of the 30, 60, 90, we're going to do that one first. Here's my 30, here's my 60, here's my 90. The pattern for 30, 60, 90 was what? Tell me the pattern. Fabulous. And what piece of information for this triangle were we given? The 16 is across from what?
90.
The 90. So that means this is going to be 16 right here. If 16 is 2x, what is regular x? 8. Which means across from my 60-degree angle is what? 8 square root of 3. Okay, let's pause for a second. We wanted to find x. It's one of the things we're finding. X is across from what? The 60. Didn't we just find that? So what is x equal to? 8 square root of 3. We'll write that one down since we already found that. X is 8 square root of 3. When we set up our second tic-tac-toe boards, the second triangle is a 45, 45, 90 triangle. It's my other special right triangle. This was on the front page. We did this on the whiteboards. What was the pattern for 45, 45, 90? X, 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 and then X square root of 2. Okay, let's figure out what we know so we can fill some stuff in. What number from the small triangle do we know? Do we know, look at where my arrow is pointing. Do we know this?
45.
We know that they're 45, 45, 90. Do we know this side length?
No, we know the height.
We know the height. We just found the height as part of the 30, 60, 90 triangle. This is across from the 30. So how high is it? It's 8, which means I was given that one of the 45 degrees was across from an 8. Which means the other 45 degrees would be what? 8. And then across from the 90 would be? Okay, now let's just answer the questions. We've got our tic-tac-toe boards. The letter Y is across from a 45, which means the letter Y is how much? 8. The letter Z is across from a 90. So how much is letter Z? There we go. We know how to answer this question. So Y was 8 and Z was 8 square root of 2. These tic-tac-toe boards are going to be very, very helpful for you in solving just these special right triangles. Now notice, we've only worked with 30, 60, 90s and 45, 45, 90s. Those are the only triangles that have these special relations. Don't try to do this for like a 15, 90, and 75. They don't work. They don't have this ratio. It is only these special right triangles. Okay? Let's go back to our whiteboards and let's try some more problems. So same way we did before. As a help, don't forget you have that orange reference sheet you just picked up. Right in the middle is the patterns that I was just talking about. So you don't have to flip back and forth in your notes. You can just look at that orange paper.